Intro to Algebra, Lesson 1-4B. Last time we were discussing equations, inequalities, and using the expressions on both sides and making sure there's an equal or an inequality sign in between them. Now, we take this a step further and we try to use some formulas in our ability to evaluate to see if we can solve some story problems or other situations. So our first example, we need to be able to translate. Since math is like a language, we need to be able to take things we have verbally and rearrange them so that they become mathematical expressions. So there are certain key words that we must always pay attention to. For example, in this problem, the word sum. The word sum tells us that we are in fact dealing with an addition problem. If you hear the word product, it means multiplication. If you hear the word quotient, you know you're dealing with division. If you hear difference, you know you're dealing with subtraction. So in order for you to add something, there has to be two values that you're actually adding together. You can't just take the number 5 and add it. It has to be take 5 and add it to 7. Or take 7 and 5 and add them. But there has to be two things. So if I were to translate this, I know I have an addition sign. The two things they want me to add are right here, x and 16. So I write them as x, and I write it as 16. The next part here says is less than. Is less than is not an equal sign. It's an inequality. One of them is less than the other. In fact, it's that inequality. So I go ahead and I put that inequality there. And it's less than what? It's less than 32. A fairly important amount to put down. So in words, it says the sum or addition of x and 16 is less than 32. As an expression or an equation or an inequality, I translate it into math, and I still say the sum of x and 16 is less than 32. So it has been translated. The product, all right, the product of 16 and x. The word product tells us multiplication, all right? Maybe you'd rather I write a dot. Multiplication. And again, just like sum, you can't add one thing to something else. You can't multiply one thing. You can't just say, multiply 5. 5 times what? It's got to have two pieces. So the two pieces it's talking about are right here. That's what we want to multiply. So 16 is going to get multiplied by x. Now it says is less than. Less than, once again, is this inequality of the 32. So words converted into math. The product of 16 and x is less than 32. I translated those words. We have a number of formulas that you could use. Some of them will look familiar to you, or at least somewhat similar to things you've seen. So for some of the formulas, we have the area of a rectangle. Fairly easy. Most of you have seen this one for a while. Since there's no operation sign between the two letters, we know it's multiplication. A stands for area, L stands for length, and W stands for width. If you want to know the area of any rectangle, you take the L times the W, the length times the width. Simple interest, we've talked about this as well. I stands for interest. P is the principal, which is a fancy word for the starting or initial amount. R is your rate. It'll be a percentage, so it'll say like 4%, 5%, but make sure you convert it into a decimal. So 4% needs to be put down as 0.04. 8%, 0.08. Always move it 2 places to the left. And then T stands for time. Typically that's in years, so if it's annually, that'll be times the years. If you wanted 6 months, you'd have to put in 0.5 for time, because that's half of a year. Temperature. If I told you the temperature in Fahrenheit, you could put that value in for F for Fahrenheit. If I wanted to know what it equaled in Celsius. So let's imagine the temperature 32 degrees is a freezing temperature for water in Fahrenheit. At 32 degrees Fahrenheit, water will freeze. If I want to know what temperature that is in Celsius, I put the 32 here. 32 minus 32 makes 0. Then 0 times 5/9 is still 0. So 32 degrees Fahrenheit is the same as 0 degrees Celsius. They're the same. If I wanted to know what it was at 80 degrees Fahrenheit, I'd stick 80 in, subtract 32, get another number. I would take that number and multiply by 5, get another number, and then lastly divide by 9, and it would tell me the Celsius. The distance formula, D for distance equals R, the rate. In this case, it's not the same rate, it's a speed, times time. You might be dealing with minutes, hours, days, months, years, it all depends. You might be dealing with miles, kilometers, inches, feet, it all depends. But whatever units you're using here, your rate will be an expression of that. If this is miles and that's hours, then this will be miles per hour. If this is kilometers and that's days, this will be kilometers per day. It all depends. And the volume of a cube. V for volume, what's significant is a cube, all the sides are exactly the same. So instead of saying, I thought the volume of a rectangular prism was length times width times height, which it is, a cube is a special form of a rectangular prism, where all the sides are the same. So you can just say S, cubed. That's no different than saying length times width times height, but all the length, width, and height are the same, which means S times S times S is S cubed. That's why it's that formula. And the surface area of a cube. Again, since it's a cube, it's going to have all the sides be the same. If we have the shape, there are 6 faces on a cube. The sides, the tops, and the front and the back. 6 of those sides. If you want to know the area of just one face, just the area right here, then you would have to take one side and multiply it by the other side. That's why it's side squared. That gives you the area of one face. Take that value, multiply it by the 6 faces that we currently have. Example number 2. Which formula would you use to find the average speed of a car that travels 80 kilometers in 2 hours? So we know we want to find speed. And we know that we're traveling 80 kilometers, and we know that we have 2 hours. So when we go back to our list of formulas, there's only one that really involves those 3 values right here. D equals RT. Distance is equal to the rate times the time. Now there's actually 3 variations of this exact same formula. In this case the formula has D alone, but it is possible to say R is equal to distance over time, or you could say time is equal to distance divided by rate. Notice this one has D alone, this one has R alone, this one has time alone. But they're the same relationship. Out of these 3, I think we're looking for the speed, so this would be the best one to use. We could say R equals the distance of 80 kilometers and a time of 2 hours. Now, 80 divided by 2 is 40. 40 kilometers per hour. That's how fast we're going. Every hour, 40 kilometers. Another hour, 40 kilometers. We went 2 hours, 80 kilometers. Logically, it makes sense. Which formula would you use to find how long $5,000 should be invested? Invested means put in. So that's your start amount, which we refer to as the principal. At an annual, that means per year, at an interest rate of 4%, 0.04, to earn $500 in interest. I equals P times R times T. This question is asking us how long, which means it doesn't know the time. We need to substitute all the values we know. The interest is $500. The principal was the starting amount invested, was $5,000. The rate is 0.04. The time we do not know. So we multiply. This value right here can be simplified. We should be able to multiply those two. 500 is equal, now we got to figure out what 5,000 times 0.04 is. Right? Take this down just so we can pull up our calculator. 5,000 multiplied by 0.04 gives us 200. We now know that we have 200 times t. Now 200 times 1 is only 200. 200 times 2 is 400. 200 times something makes 500. Divide both sides by 200, which is a little advanced for what we're doing, and you get 2.5 equals t. And this was in annual, so we would say this is years. If we had $5,000 to invest at 4% simple interest, we could leave it in for 2.5 years and it would make us $500 just for sitting there. The last example, which formula would you use to find the length of each edge of a cube? Dealing with a cube tells me we must have this. That use 24 square inches of lumber to make. That's it. This is a hard problem. The fact that there's 24 square inches of lumber is telling us that all 6 sides, this side, plus this side, plus this side, the back side, the bottom, and the left, all 6 faces create the 24 inches squared, which means the surface area, remember, is 6s squared. This is the surface area we have. This surface area is right here, 24 inches squared. So 24 is equal to 6s squared. You can figure out dividing by 6 to both sides, and we end up with 4 is equal to s squared. Now you tell me, what number times itself is actually equal to 4? The answer is 2. So now we know 2 is equal to s, and these are 2 inches. And it says, find the length of each edge. 2 inches would be the length of each edge.